students, and welcome to the second lesson of differentiation, where we will talk about application of differentiation in kinematics. In our first lesson, we had looked at differentiation, and we majorly looked at application of differentiation. We looked at stationary points, how to differentiate equation of the normal and equation of the tangent. Now, today we will look at application of differentiation in kinematics. This marks our second and last lesson about differentiation. Now, dear students, if it's your first time to key in this channel, subscribe, like, and share. This will help you to be the first one to get the notification of our lessons. Now, students, we know how to differentiate. Doing a recap on our last lesson, we said that about differentiation, we have two major things to know. The first thing is that given an equation, like for example, 3x, y is equal to 3x squared plus 2x plus 2, when we differentiate the y dx, y dx, we say that the first step is to bring the power down, then we reduce the power by 1. Students, if we have such like an equation, the first step is to bring the power down. Given this one, it will be now 6x plus 2. This gives us what we call a derivative function. Back to the lesson of the day. Here we want to understand how this kinematic is applicable in differentiation, or how we can apply differentiation in kinematics. I know you are asking yourself what kinematic is. We need to first of all understand the word kinematics. So students, let's say that kinematics is the study of moving objects, bodies. That's all about kinematics. It studies what we call moving objects or moving bodies. Now, today we want to know how is it important that we have differentiation in kinematics. So here, when we talk about moving objects, there in linear motion we interacted with things like velocity, speed, displacement, distance, acceleration. Now, those are the terminologies that we are going to meet again in this topic. Now, what is important to note is that point number 1, given a displacement equation, stroke distance equation, comma, we differentiate to get a velocity equation. So what does that mean? That if we have a displacement equation and we differentiate, at the end of the day, whatever we get is what we refer as a velocity equation. Point number 2 says that given a velocity equation, comma, we differentiate to get an acceleration equation. This is very important. These 2 points are very necessary and very, very important. We have a velocity equation. We begin by having what? A displacement stroke a distance equation. When you talk about velocity, it's just the same as speed. Then we have what we call acceleration. So having the 2 points, we can therefore say that if we have a displacement equation, we we differentiate to get our velocity equation, differentiate to get our acceleration equation. That's all. So what is very important here now is to look at examples that we have when it comes to this. Now let us do some two examples about this so that you can be able to understand. So example number one, let us look at it. Say that the displacement comma s meters. Remember, displacement is given in meters. Covered by a moving particle after time t seconds is given by s equal to t cubed plus 4t squared plus a minus 8t plus 3. That's the question. Now, part A said find velocity at t equal to 2 seconds. Part B, find acceleration at t equal to 5 seconds. So this is the question, that the displacement s meters covered by a moving particle is given by after t seconds is given by the equation s stands for displacement, 2t cubed plus 4t squared minus 8t plus 3. That's our question. Now the question says find the velocity at t equal to 2 seconds. Then part B, find the acceleration at time equal to 5 seconds. Let us be able to navigate through that question. So dear students, we say very well that given a displacement equation, when we differentiate we get a velocity equation, when we differentiate we get an acceleration equation. So the question is giving us the displacement equation, and here we have the question demands we get a velocity at time equal to 2 seconds. So the first very important step is to get the velocity equation. That's very important, to get the velocity equation. Now, velocity, we say that velocity equation, for us to get the velocity equation, is given by dy, is given by displacement, by finding the differentiation of this equation, of this displacement equation, or what we call the derivative of this equation. Now, ds dt is given by, we have this equation, 2t cubed plus 4t squared minus 8t plus 3. So if we differentiate this equation, the first thing is that we bring down the power. It becomes 6t squared. Then we reduce the power by 1 plus, it becomes now 8t minus 8. That is now our velocity equation. So after getting the velocity equation, the question says at time equal to 2 seconds. So we replace where we have time with 2. Where we have the value of t, we replace with 2. So it is 6, 2 squared plus 8 into 2 minus 8. So here is 2 squared is 4. 4 times 6 is 24 plus 16 minus 8. Now, we have this, it is 40 minus minus 8, the answer is 32 meters per second. Yes, students, this is how we do that question. That the first step, given a displacement equation, to find the velocity equation, you differentiate the displacement equation. After doing differentiation, you look at the demand of the equation. That find time when t equal to 2 seconds. Sometimes the question demand that we stop here. Then the question will say you find the velocity at any given time. When they say at any given time, it simply means you give out the equation. Or they can also say find the velocity equation. That's the first part of the question. Now we move on to the second part of the question. So the second part of the question says what? Find the acceleration. The acceleration at time is equal to 5. Remember very well we said that if we have a displacement equation, differentiate we get our velocity equation, we differentiate we get an acceleration equation. So they want acceleration. We don't go back to displacement equation. Here we go to velocity equation. We differentiate to get the acceleration equation. Or if you want to go back to the displacement equation, it means you differentiate twice for you to get the acceleration equation. Now, here we have the velocity equation. We say that dv dt, so velocity, we say that acceleration is given by dv dt. So we differentiate which equation? Now we differentiate the velocity equation. Students, it has to be there, plus 8t minus 8. So if we differentiate this, we will be able to get what? Acceleration equation equal to, now we bring the power down, 12t minus 8. That is our acceleration equation. The question says find acceleration at time equal to 5. Where we have t, let us be able to replace with 5. So acceleration equal to 12, 5 minus 8. So this one is giving you 60 minus 8, you get 52 meters per second squared. Units are very, very paramount. They are very important when it comes to mathematics. We mark correct units. If you are not aware with the units, be sure you don't put there because you cannot use wrong units. That's how we do it. That's the first example about the question. But now, students, what is very, very important is to understand the concept. I want us to do the last example, but before we do that, ensure you get the steps very clear. Yes, students, if you've not subscribed, be sure you click that bell. That shows that now you have subscribed to this channel. Anytime we upload a new lesson, you will be able to get a notification of new lessons. Now, let us move to another example that will be able to conclude our lesson in a very good way. So, dear students, let us move on. Now, there are different versions in which the examiners put these questions. Their intention is to bring some confusion at you so that you can fail the question. But you are supposed to, let us do another example so that we can be able to get this one very clear. Now, example 2. I say very well that there are different versions in which examiners can be able to put this question to bring some confusion unto you. But we are going to look at it. Now let us do this question. Say that a particle moves in a straight line. A particle moves in a straight line such that t seconds, such that after t seconds, its displacement s meters from a fixed point, is given by s equal to 4t minus 2t squared minus 5t cubed. Find part A, velocity at t equal to 3. Velocity at t equal to 3. Part B, time when the velocity when the particle is momentarily at rest. When the particle is momentarily at rest, then C, say that acceleration at t equal to 2 seconds. Students, let us do this question in a very serious way. That a particle moves in a straight line such that after time t seconds, its displacement is given by this equation. Now finally, we say that find the velocity at time equal to 3. Find the time when the particle is momentarily at rest. Then find the acceleration at t equal to 2 seconds. Now students, let us be able to navigate through this question. Let us come back to the question. So we want to do this question so that we can be able to understand other new concepts. So part A is asking us to get the velocity, and this is very simple. We have been doing this. Say that if we want to get the velocity, we first of all get the velocity equation by differentiating the displacement equation. Say that ds dt, that's velocity is given by ds dt. Then we have that 4t minus 2t cubed minus 5t. So if we differentiate this, we will get our equation as velocity equal to 4 minus 6t squared minus 5 minus 5. So dear students, let us be able to understand this. Remember, this was 2 squared and this was 5 cubed. So when we differentiate, it simply means we will get 4 minus 2t. Then this one will become 4t minus 3, that is 15t squared. That's our velocity equation as per the displacement equation. So after differentiation, we get it as 4 minus 4t minus 15t squared. Now, after getting the displacement equation, we replace where we have velocity by t3. So velocity is given by 4 minus 4 into 3 minus 15 into 3 squared. Now, dear students, for us to get the velocity, we now compute. We have 4 minus 4 times 3, we get 12, minus we have 15 times 9. That is now our velocity equation. Now when we compute this, we get so we have 4 minus 12 minus 135. So we get 4 minus 12 minus 135. We we get our velocity as negative 143 meters per second. But students have to write in here, we neglect the negative so that we ensure our velocity is positive. So velocity is given by 143 meters per second. Hope it is well understood. Let us be able to check, follow the procedure very well. The concept is very simple. Given a displacement equation, differentiate to get a velocity equation, then replace where necessary. Now students, hope this one is very clear. We want to move on to the next part of the second part of this question, which says find the time when the particle is momentarily at rest. So when you talk about momentarily at rest, what does it mean? When you talk about momentarily at rest, it simply means the velocity of the particle is zero. The velocity at that point will give you what we call zero, because it is momentarily at rest. Moving when it comes to a stop. So students, when you hear anything to do with momentarily at rest, it simply means the velocity of that particle at that point is zero. So if we have our velocity equation, which we've differentiated, we got 4 minus 4t minus 15t squared. So this is our equation. It is a quadratic equation. We say that the velocity is 0, so we equate velocity equation to 0. Therefore it is 4 minus 4t minus 15t squared is giving you 0. This is a quadratic equation. So we rearrange according to the form of quadratic. And therefore we have this 15, so negative 15t squared minus 40 plus 4 equal to 0. So this, we remove this negative sign on the outer side. It remains now 15t squared plus 40 minus 4 equal to 0. So we solve this quadratic equation. We have so many methods that we can use to solve this quadratic equation. We have the use of quadratic formula. We have use of what we call, we can use product and sum method. Also, you can go ahead and use completing square method. You choose the best method for you as long as you get the value of t. Now for this case, students, we will use what we call quadratic formula, which states that minus b plus or minus square root of b squared minus 4ac over 2a. Now that is the quadratic formula that we are going to use to get the value of t. So this is a, this is b, and this is c. So minus b, so we say that minus 4 plus or minus 4 squared is 16 minus 4, value of a is 15, multiplied by c, which is 4. All over, the value of a is 15, so it is all over that. Now, when we replace these students, we will be able to get the value of t. So there, when we replace this 4 times 15 times negative 4, then it is now, we do this in a bracket, so we get 16 . So students, when we do this, we get 15. So we have minus 4 plus 15 all over 30. So we have minus 4. We begin with minus, that is minus 4. Here it is plus or minus. So we have minus 4 plus 15 divided by 30. So we get time as 11 over 30 seconds. That's the first one. Then the second one we have negative 4 minus 15 divide by 30. So you get a negative answer. You get around negative 13 over that. So students, time cannot be negative, so we neglect the negative and we remain with time equal to 11 over that. So that's how we do it. Now, point to mark that when they tell you momentarily at rest, it simply means velocity of that particle is 0 at that point. Now let us navigate to the last part of this question. This says acceleration at time equal to 2 seconds. We say that for us to get acceleration, we differentiate the velocity equation. Say that dv dt equal to, we have our v velocity equation, that's 4 minus 4t minus 15t squared. Now, dear students, when we differentiate this acceleration equation, we will be able to get negative 4 minus 30t. So this is giving us the acceleration equation. Now, having this acceleration equation, we replace with t as 2. So acceleration equation is given by negative 4 minus 30 times 2. So we get negative 4 minus, that one is 60. So negative 4 minus 60 gives you negative 60 meters, negative 64 meters per second squared. Remember, when we have a negative acceleration, it means it is decelerating. The particle is decelerating. It is reducing velocity over time. We call it retarding in physics, or retardation. Now, up to that point, students, we are almost coming to the end of our lesson today. If you not subscribe, I urge you to subscribe, like, comment, and share. So this will give you an opportunity to be the first one to get these videos. Now, students, I want to talk about something very important, key points to note in this part of our lesson today. Note that there are some of the terminologies that are used by examiners to trick students. Number one, they tell you that particle find time when the particle is momentarily at rest. Say that this means the velocity is 0. Then number 2, say that at find time at maximum velocity. So at maximum velocity means, at maximum velocity it simply means that the acceleration is 0. So acceleration here is 0. Here velocity is 0. Then they can also tell you that find time, find velocity maybe, or find distance or displacement, or acceleration at what you call, say that at. When they say at initial velocity, when they say at initial velocity. So when you talk about at initial velocity, this simply means that time is 0. So time is 0. Time is 0. Now, students, I want to take this opportunity to thank you very much for giving me a very attentive audience to this class. This is our last and second lesson about differentiation. We are preparing other lessons on integration and other topics. Let us be able to subscribe and get a notification of new lessons. Thank you very much. Let us meet in